In today's video, we'll be creating this geometric tunnel loop. It's going to be using geometry nodes and it's going to be very simple. And with that, let's actually begin the tutorial. In our default scene, we're going to bring our cursor to the junction of these two windows, click and drag to create a new window, and we'll change this from the 3D viewport to the geometry node editor. Then we'll press this plus button to create a new geometry node tree. We'll zoom in, select the group input, and then tap X to delete it. Now, essentially, we want a torus, and to create a torus in geometry nodes, we're going to be searching for a curved circle, and we're going to be converting this curve into a mesh using a curve to mesh node, as you can see over here. Now, for the curve to mesh node, you need to give a profile curve, and that is going to be a curved circle itself. So we can just press Shift D to duplicate that. And now if we take this and plug it into the profile curve, we should get our torus. Now we can change the properties of this torus by playing around with these values over here. And to make it a larger torus, we're going to first start by increasing this radius to something like 2 meters. Then we can reduce the thickness of the donut by changing this radius down like that. But I think a value of something like 0.9 will be good enough. Apart from that, we don't need such a high resolution. So let's reduce this all the way down to something like 6. And similarly, for the main torus, let's reduce the resolution down to something like 7 or 8 so that we get some sort of a shape like this. Now over here, it's shaded smooth, so it's really hard to tell where the faces are. So just to be able to see the faces, let's press Shift A and search for a set shade smooth node and then uncheck the shade smooth so that it becomes shaded flat. Now you can see we have these rectangular faces, but I genuinely want triangles to be present in the faces. Now if we were to directly convert these to triangles by using a triangulate node, you wouldn't be able to actually tell the triangles. Of course, they are triangles. If you switch to wireframe view, you can see, but essentially they're just going to be adding in one diagonal, which doesn't look too good. So what we can do is we can actually use this and then search for a dual mesh node and plug that in after the triangulate node. Now, when we switch over to our solid view, we can see how we get these hexagonal shapes, and from these hexagonal shapes we can triangulate it once again. So let's press Shift D and plug that in here, and this time instead of beauty we'll change it to clip, and now you can see you get these really abstract geometric triangular shapes present all around the torus. Now at any point of time, if you don't like the shape, you can always come back here and play around with the resolution and things like that till you get exactly what you're happy with. So by increasing the resolution here, you get more and more faces. Maybe we'll go with a resolution of 15. Now although we have these triangles, it would be a much more dynamic animation if these triangles were actually moving around. So to move them, we can shift this over to the side and press Shift A and search for a set position node. Now let's plug that in after the triangulate, and for the offset, let's control it using a noise texture. Now we have to loop this noise texture, and we've done that in multiple videos before. Be sure to check out other videos on my channel if you haven't already. And we're going to mix these two noise textures using a mix color node. We have to take the color from both the noise textures and plug them into socket A and B respectively, and change these from 3D to 4D. Apart from that, remember that this noise texture currently is going from 0 to 1, which means it's centered around 0.5, and it'll shift everything up towards the top right. To prevent that, we can use a vector math node and change this from add to subtract, and subtract a value of 0.5 on all of the axes down here. We can take this result and plug it into the first socket, and to have better control over this as well, we can press Shift D to duplicate it and change it from subtract to scale. Now if we plug this vector in, we can increase the effect of this noise by playing around with this scale value. Let's now plug this into the offset and see what we get, and this is what it looks like. If you change the W value, this is the sort of motion that you get, which is a slight wiggling motion. If you want to increase this, start increasing the scale and you would get a much stronger wiggling effect. So I'm going to keep this at a value of something like 1.5, and then we're going to be playing around with the W value just for this sort of a subtle motion. We'll deal with that in the animation section, but for now, let's continue building this node tree. The next thing that I want is to separate this out into two separate geometries. The first one being these faces but scaled down, and the second one being these edges converted to a wireframe. So we can press Shift A and search for a join geometry node so that we have both those geometries present, and then to first split the faces, we'll press Shift A and search for a split edges node. We can plug that in, and now we have each face separated out. If we search for a scale elements node and plug that in after the split edges and just reduce the scale to something like 0.85, you can see how each face scales down individually and it becomes like this. Now beyond these faces, I also wanted the wireframes to be present. So let's press Shift A and search for a mesh to curve node, plug that in after the set position just like this, and then convert it back to a curve using this same curve to mesh node. So press Shift D and plug it in here, connect the curve to the curve, and for the profile curve, we can use another curved circle. However, because we just want a thin wireframe, we're going to have to reduce this radius from from 0.9 to something really small. Let's go with 0.005 and then plug that into the profile curve. Then take this mesh and plug it into the joint geometry, and now you can see we have the wireframe present as well. Now I want a few of these faces to light up, and for that I want to control it using a random value, and instead of generating a changing random value, since I do want it to loop, I can just take this result and use this itself. However, to use this random value in the shader editor, we're going to have to store this as an attribute. So let's press Shift A and search for a store named attribute, plug that in after the scale elements, and change this from float to color because we're storing a color value. Then we also want to store one color for every face, so we're going to have to change this point from point to face. Then we can take this result and plug that into the value, and now we'll get a looping random noise value for each face separately. We have to give this some name, so let's name this RAND face because it's a random value for every face. Now we need to just set the materials, and we should be done with the geometry node setup. So for the setting of material, let's press Shift A and search for a set material node, plug that in right here, press Shift D and plug it in here, and then select the materials. Remember, right now we have only one material. Let's rename this to faces, and then press this plus button to add in a new slot, press this new button to create a new material, and this time we'll call it wireframe. Now since this is the wireframe, we're going to select wireframe from here, and since these are the faces, let's select faces over here. With that, we can start off the animation section. So let's go to our output properties, change the frame rate to 30 frames per second, end frame will keep it at 300 so that it's a 10-second long loop, output folder will keep it wherever we want to save it, file format I'm going to choose FFmpeg video, encoding I'm going to keep the container as MPEG-4, and output quality I'll choose perceptually lossless. Then on these noise textures, I'll change the W value to 0 as well as the factor down to 0 as well. Then I'll increase the timeline a little bit, press the back arrow to go to frame 0, hover over this W and tap I, hover over the factor and tap I, and change this W to some value that will suit the scene. I'm just going to go with 0.5, and remember, the higher the value, the faster the wiggling is going to happen. So I think a value of 0.5 will be good enough, so I'll keep it at 0.5 and tap I. Then I'll go all the way to frame 300 by dragging my cursor till here and then clicking right there and changing all of these values. Remember, this W has to be the negative of whatever this value is. So let's go with minus 0.5, then tap I. Factor I'm going to change all the way to 1 and tap I, and this W I'm going to change down to 0 and then I'll tap I. Now I have to shift select all three of these nodes, come down to the timeline over here, press T and choose linear. So that way we should get a smooth loop of this moving or wiggling in 3D space. Next we have to animate the camera. So let's select the camera, press Alt G to clear its location, Alt R to clear its rotation, followed by RX90 to rotate it on the x-axis by 90 degrees. Then we can press GX2 to bring it to the center of this torus. Now to animate the rotation, we'll add in an empty which will act as the controller. So let's press Shift A and add in a plane axis empty, then select the camera, shift select the empty and press Ctrl P, set parent to object. So now the camera is the child of the empty, and we can animate the empty to rotate about the z-axis. So on frame 0, we'll tap I, rotation, and then on frame 300, we'll press RZ 360 and then we'll tap I, rotation. Down here, we'll press T, linear, and that way we'll get a smooth loop of the camera moving through the torus one full round. But it still won't look too good if you go into the camera view by pressing 0. So to fix that, let's first select the camera by expanding the empty down here and selecting camera, going to the camera properties and starting off by changing the focal length down till a lot more comes into view. This gives it a much wider field of view, and hence there will be a lot more distortion towards the edges, but that actually adds to the abstract effect. Then we'll expand the viewport display, increase passport out all the way to 1 so that we don't see anything outside our camera view, so we get an accurate representation of what's going to be rendered. To make this even more dynamic, on frame 0 with the camera selected, we'll tap I and just choose rotation. Then on frame 300, we'll press R, Z twice to rotate it about the local z-axis, and we'll choose 360. Then we'll tap I, rotation, and just like last time, we'll come down here and press T, linear, so that we get a smooth loop where the camera also rotates about its local z-axis, which gives it this sort of a dynamic effect that I think looks absolutely perfect for this particular scene. Once you're happy with the way all of that looks, you can go ahead and start the actual texturing. For that, we'll go to our render properties, switch on bloom and screen space reflections. We'll expand the bloom and just change the intensity down to maybe 0.02, and we'll clamp it down at something like 5. Then we'll select our cube material, switch over from the geometry node editor to the shader editor, and also switch the viewport shading to render so that we can see what we have. We'll switch off overlays, select the default light, and hide it for the time being. Now with the cube selected, we can start playing around with the different materials. First off, we'll go to the material properties and choose faces so that we deal with the faces first. For all of the faces, I want them to have a base color of something a little purplish, just like that, and I'll make it completely excessively bright. However, I'll make it very much metallic and I'll reduce the roughness down to maybe 0.3 so that there's a lot more reflections. Then I want a few of these to be lit up. So I'll have to search for that attribute that I created. So we can search for an attribute node and give it the correct name, which was RANDFACE. So now that we have the attribute here, if we directly plug this color into something like the emission, we should see different faces light up at different levels, which means that yes, our attribute is being passed in over here. Next, we'll press Shift A and search for a color ramp node, which will allow us to select just a few of these faces and determine the color or the strength. So we're gonna keep it plugged into the emission color itself. We'll bring this in just like that until we have a few of them lit up. We'll increase the emission strength to something really high, and because we have it clamped over here, it shouldn't cause too much of an issue. Remember, if we switch off the clamp by changing it down to 0, there will be too much brightness, so make sure you keep it clamped at an appropriate value. Then we can change the color by selecting this and giving it maybe a yellowish color or an orangish color like that. You can drag it in according to what you think suits the scene, and I think something like that is alright. Now when you play the animation, even the faces that are lit up will slowly change over time because we're using the random face attribute, which was created by a noise texture that was looping and changing over time. However, don't be fooled with the way this looks right now because the background is still gray, which is giving some type of light, and although that might look good for your lit scene, the background shouldn't look like that. If you like it, you could keep the background just like this and use a light path node to make the camera rays completely black by duplicating this background node and changing this to black, plugging this into a mix shader node, as you can see over here, and then taking the camera ray output from the light path and plugging that into the factor, which will make everything inside the scene be lit by this value, but our camera will see black, which shows black over here. Now, if you like this, good enough, but for the time being, I'm gonna just use the plain background and change this all the way to black. I'll then light up the scene using this default light itself when I get to the lighting and background section. For now, back in my object materials, I'll switch over from the faces material to the wireframe material, and for the wireframe, I'll just make it a complete white and I'll increase the metallic all the way to 1 and I'll change the roughness to 0.4. In fact, I'll give the base color maybe that same orangish yellowish color, but I might change this just before rendering. Next, on frame 0, I'll unhide this light and press Alt G to clear its location, and then I'll select the camera and press Shift S to bring up this menu, and I'll choose cursor to selected. That way the cursor will be present exactly where my camera is, and you can see that if I just switch on overlays, the camera is present right here and the cursor also appears right there. Then I can select the light and press Shift S and choose selection to cursor. So that way the light comes to exactly where my camera is, and then I can control click the camera in the outliner over here, then bring my cursor here and press Control P and choose set parent to object. So that way the light will also follow along my camera. Then I'll expand the camera, select the light, go to the light properties and reduce the power from 1000 watts to something like 10 watts. And I think this actually looks a lot cooler than having my entire world lit up. Of course, you can increase this power or reduce this power based on what you think suits the scene, but I think this is good enough. Next, for the background, I still don't want it to seem like there's absolutely nothing present outside this particular chain, which means I need to change this black from a complete black to something that's visible. To create that, I'm actually going to just select this, go back to the geometry node editor and press Shift D to duplicate it and create a new cube. But for this one, I'm going to come and press this button to duplicate the geometry node tree so that I can make changes to it individually. I'm going to remove all of these nodes by tapping X because they're not needed, and I can just focus on the singular node tree which will be created. If you have Node Wrangler enabled and let's say I don't want this node, I can press Ctrl X to just delete it while retaining the connection. Similarly, I no longer need this joint geometry, so Ctrl X and I just get a simpler geometry node setup. Then I can go ahead and just increase this radius over here and also switch off my overlays so that I can see what it looks like at the moment. By increasing the radius, you can see that it goes completely outside this particular torus, but you can still see it in the background. I want to give it its own material, so let's press this plus button to add in a new material slot. We'll add in a new material. We'll call this outer torus, and we'll select that in the set material node. Now we'll go back to the shader editor, and with outer torus material selected, we'll increase the metallicness all the way to 1. We'll change the base color to maybe the orangish color, and we'll also reduce the roughness down to maybe 0.25 or something like that, just so that there are nice reflections as well outside this particular torus, which makes it look like this. And I think that looks pretty cool. With that, we should be done with everything for this scene. And if you're happy with the way it looks, you can go ahead and press render animation. I hope this was an easy one to follow along, but the technique techniques used, just like every other video, can be implemented in various different animations or motion graphics based on your requirements and the scene that you're trying to build. The aim of these tutorials is for you to get different ideas for inspiration and also learn separate techniques that you can implement while creating your own animations. If you've watched so far into the video, thank you so much for watching, and I highly recommend checking out other videos on my channel because I post videos every single day and I'm sure there's something or the other just waiting for you to discover. Until my next video comes out tomorrow, thank you so much for watching again, keep creating, and don't forget to stay creative.